Hello everyone and welcome to this new session for ETL Amazon RDS to Redshift. So very warm welcome to all of you. Let me introduce myself first. I am Jatin Goyal and I am an AWS authorized champion instructor. So before starting this particular session, let me give you a quick overview about myself with respect to what I am holding, why I am here, and what I am going to help you out in today's session. So if we'll go through here, I am an AWS authorized champion instructor, as I told you before. So I'm holding all these certifications, all these tags from the AWS. I'm holding all three associate level certification along with data analytics specialty, and I am a cloud practitioner essential certified. I'm also an accredited instructor, restart instructor. And if you want to connect to me, you can scan this QR code and you will be redirected to my LinkedIn profile. Okay. Now, coming back to the point, what we are going to cover in today's session. So, our today's agenda is to give you an overview of how we can perform an ETL from RDS to Redshift as a part of this Redshift series. Okay. So we are going to talk about Amazon Redshift from the overview perspective. We will have a quick discussion on overview of Amazon RDS. I will be giving you an idea on services we are going to use in this demo. And finally, I'm going to show you a hands-on for the demonstration to perform ETL from RDS to Redshift. Okay. Now, first thing, like when we start in AWS, we know that AWS offers 200 plus of services which we can use with our day-to-day practice. Okay. In AWS, we have managed database services available, which you can use based on the requirement you have or which fits into different use cases. Soon, I'm going to help you out with one blog where you can have a quick idea on different database services available with respect to their use cases and what are the scenarios those services will be fitting into. Okay. So if I talk about Redshift at a very high level, you know Redshift provides you a data warehousing solution. Okay. When we say data warehousing solution, if I have to define data warehouse in a very simple statement, I can say it's a centralized repository which is containing structured data ready for the analysis. Okay. As we know, data is an important pillar of any industry. Every company is dealing with the data. And the idea, the goal behind that is to understand customer requirement, is to understand customer behavior. So companies can focus more on the business growth. Okay. So now we need some repository to place our data, to keep our data so that we can use it for the analytical purpose. So we categorize Redshift into the analytical databases. At the same point of time, if I have to talk about RDS, which provides you a managed relational database service in the AWS, it is basically used for transactional processing. Let's say I have to perform my day-to-day transaction and it is providing you the compatibility with the SQL queries. Okay. It also provides you supports for different database engines. Like soon I'll show you when I am going to create RDS database that what are the supported database engines available. Okay. And if I'm going to talk about ETL AWS Glue, that is a serverless ETL service where you can perform extract, transform, load. Okay. Now, why there's a need to perform ETL operations? Think about it. Not all the data is in a form I want to use it for the analysis purpose, because we know that we can get data from different sources in different formats with different size and structure. We can have structured, we can have semi-structured, we can have unstructured data too. Okay. So basically, like before we are importing our data to Redshift, which is going to provide us a centralized repository, if required, we can also perform transformations. Now, transformations can be in various ways. Let me give you a very simple example. Let's say you have two databases. One is your source database, another is your destination database. And now my requirement is to import the data from source to destination. Okay. So as a part of the database, I have a table called employee table. Okay. That is containing various attributes having a particular data type. So let's say while importing the data from one database to another database, I have to transform the data type of a particular column. I can do that. If I have to perform some aggregations, I can do that. If I have to perform some join operations, I can do that. More about the transformation, I will tell you when I am going to show you AWS Glue and when I'm going to create a job in AWS Glue. Okay. So now let's quickly move towards the demonstration. So for that, I'll help you out. But before that, let me just pass on this article in front of you. You can simply type on internet AWS database services and it will give you this blog. Okay, if you will read this blog, you can see modern applications with free databases on AWS, how you can build that. But for this, you need to understand what are the offerings which are available in AWS. Okay, so you can see these are different offerings. Okay, we have different type of solutions available, and the best part about it, like you can see this column where there is a description, like when you can use it or what are the proper ideal scenario. You can also hover over it. Let's say if I have to go to a particular database offering, I can simply open the link and I will be navigated to a particular article where I can read about the use cases, I can read about the customer stories, I can read about how to get started, and I can also get an idea how I can explore more of AWS. Okay, so this block you can refer. Now let me come back to the demo I'm going to show you. So as I told you in my demo, I'm going to perform an ETL from RDS to Redshift. Means my source database will be RDS and my destination will be Redshift. Okay. So for that, the first thing which will be required is to create an RDS database and a Redshift cluster. So I will quickly open two tabs, one for Redshift and one for RDS. Okay. Let me do that. So once I have opened the two tabs for RDS and Redshift, let me start creating a Redshift cluster. Okay, we know what cluster is. In a very simplest language, cluster is a collection of servers. And if you have to go from the technical perspective, you can say cluster contain nodes, nodes contain slices. Okay, so in short, if I have to define the architecture of Redshift cluster, Redshift has a leader node, which is a primary node, and which distributes the load to the one or more secondary node known as compute node. Okay, each node will have a slices, which is sharing a portion of memory and disk space from the compute node, and a part of work will be allocated to the slices in the node. Okay, so let's quickly create a cluster. I will go to this navigation tab and I will click on clusters from here. I scroll down and I'll say create cluster. You can provide a name. So I'm providing a name, let's say Redshift cluster ETL demo. Okay. Now you have two options. Either you can create a cluster which is a production-based cluster, or either you can create a cluster in a free trial. If you are new to AWS, if you are planning to explore AWS services, so I will suggest you to go with a free trial. You can create a free trial account in AWS and you can enjoy the offerings provided to you by AWS to explore the services. So I'm using the one which is free trial. If I will choose this option, you can see it has automatically taken the settings in terms of configuration summary, and it has also provided you the section for the database configuration. Now here you can configure the username and password. So I'm keeping my username as AWS user only, and now I am adding a password here. Okay, so you can add any password. I have to use this password. Okay, so let me show you this. Okay, so you can set any password which you have to use further when you have to establish connection with the Redshift. Okay, let's click on create cluster. So this cluster will be created soon. Now few things you have to keep in your mind. Like when we launch Redshift cluster, there are some configurations which we need to set. Now, as I am using a free trial option, so it has automatically taken the configuration summary for me in terms of node type, node size, networking, security group. But you can customize it if you want. Okay. So if you have to customize a Redshift cluster, first of all, you will have to create all the configurations required. Either it is networking, either it is cluster parameter group, either it is subnet group, either if you want to choose a particular node type, node size, you will have to check your requirement. So for this demonstration, as I told you, I am using all default options. When I am using all default options, I will make one change here. I will make my Redshift cluster publicly accessible. The purpose or the idea behind making my Redshift cluster publicly accessible so that I can connect it from outside the VPC. Okay. By default, all the traffic to a Redshift cluster will be traversed over the internet. If you want to restrict the traffic only from the VPC, not over the internet, you can make use of enhanced endpoints in the Redshift. Okay, so I'm not using that for this particular demo. But for your knowledge, what I have done, if I will open a VPC for you, I have created one endpoint. Okay, let me show you that. So this is my VPC dashboard and I am in a Mumbai region. Okay. So you know that AWS creates a default VPC in every region when you create an AWS account. Okay. So this is my default VPC. If you will go to endpoints here, I have created one endpoint, gateway endpoint, just to show you that you can create the endpoint if you have to traverse the traffic over the private network. And I have also taken this blog working with VPC endpoints specific to Redshift. So you can read about it, where you can use VPC endpoint in order to create a managed connection between your Redshift cluster in a VPC and S3. Okay, when you do copy and unload traffic between your databases and your data on S3 stays in your VPC. Okay, so that you can read if you want to know more about the VPC endpoint with respect to Redshift. Okay, so my Redshift cluster soon will be available. Currently, if you will check the status of this Redshift cluster is creating. So soon this Redshift cluster will be available. And once it will be available, I'm going to make it publicly accessible as I mentioned in front of you. Okay. Now quickly go back to RDS management console and I am going to create a database here. So just choose create database. If you want to know about RDS in a more detailed manner, you can go here, you can read about it, manage relational database service, easy to set up, operate, and scale a relational database in the cloud. And scrolling down, you can see benefits and features, you can see use cases, okay, and you can also see the related services. Also, you have some getting started documentation which you can go through if you want to explore more about RDS. And always, when you are choosing a particular service, you need to estimate the cost based on your use case. So these are the documentations to understand pricing and cost with respect to different database engines which are available in RDS. Okay. So now, without any further delay, click on Create Database. So if you'll be clicking on Create Database, you will be navigated to the screen. Again, you have two options here: Standard Create and Easy Create. If you will read about it, if you want to use some recommended best practice configurations, you can go for the easy create. But if you want to set all of the configurations options, including ones for availability, security, backups, and maintenance, you can choose standard create. So in short, if you want to customize the settings, go for the standard create. Otherwise, you can go ahead for the easy create. Okay. I will choose my database engine as MySQL. You have different database engines available as a part of a RDS. And I told you, you can see it here. If you want to read an info about a particular database engine, simply select this radio button and click on info section. And it will open this info pane for you. Okay. So I have chosen MySQL as my database engine. If I will further scroll down, I'm just keeping the engine version as MySQL 8.0.28. You have a drop down if you want to choose a specific version. Okay. Under templates, I'm using free tier. You have more templates, you have more options available. You can make use of production, dev test, free tier. I'm using the one which is free tier. So if I will use free tier, I don't have the option for the multi-AGDB cluster, which is required to make it highly available. Okay. Under settings, I will just set the DB instance identifier. To make it simple, I'm just using the common name for the instance identifier, and this is my username. I set the password here. I confirm the master password. If I will further scroll down, I will choose the instance class, which is t2.micro. I will further scroll down. I will keep all other options as a default. Either it is from storage end, either it is from connectivity end. Only thing, I will make it publicly accessible. Okay. because I'm going to use SQL Workbench in order to connect to this database. You can also use an EC2 instance, okay, which is hosted, let's say, in a public subnet to establish the connection to this RDS database. Okay, so we'll have to wait for this database to be available. It will take some time. Okay, so let's refresh it and we'll wait for the status to be changed. In the meantime, we can navigate to the Redshift console and let's see the status of our Redshift cluster. So the status is available. Okay, let's make some changes. What change I'm going to make? Just open the cluster and I am going to make it publicly accessible. So you have different sections here, the one for cluster performance, query monitoring, schedules, maintenance, and properties. Now, if you want to explore these sections, you can. Like in a cluster performance section, you can use various metrics in order to understand the performance of your cluster, how your cluster are performing. Or you can collect various data points from here in terms of CPU utilization, in terms of percentage disk space used, database connections, and other metrics too. Okay. Now, what is the use of this monitoring? The use of this monitoring is to gain insight, is to troubleshoot in case something is wrong. Okay. And the best part about it is like you can also create CloudWatch alarms where you can monitor the data points and you can set up the thresholds. Like when your alarms are breaching the threshold, you want to take some automated action. The simplest action you can take, let's say you want to send the notifications on the basis of state change of your Redshift cluster. Okay. Now let me quickly change the properties. So I'll go to properties section. And here under properties, I'll further scroll down. Under network and security setting, I'll edit it and I will turn on publicly accessible, allow public connections to Amazon Redshift. Okay. Click on save changes. Okay. So now soon my Redshift cluster will be available. I'll have to wait for the status to be changed to available. Okay. So parallelly, I have done two things. I have launched a Redshift cluster. I have created RDS database. I'm waiting for both of them to be available. Now I have to use Query Editor version 2 in order to connect to my Redshift cluster. So at the top also you can see this info. Query Editor version 2 provides new features such as multi-statement query execution, query parameterization, query versioning, visualization, and query sharing. So if you want to learn more about Query Editor version 2, you can open the documentation from here and you can see. It's a separate web-based SQL client application that you use to author and run queries on your Redshift data warehouse. You can visualize your results in charts and collaborate by sharing your queries with others on your team. Okay. You can read more about it from the documentation. I will quickly go here and I am going to use this option to connect to my Redshift cluster. So I'm opening that in a new tab and soon this query editor will be launched. Let's check the connection. This is my Redshift cluster which I have created. This is a database, default database dev. This is a default schema, public schema. And even you will see some tables. Okay. So don't worry about this result. This is a result from my existing queries. Okay. Because I have executed some existing queries. So it has cached those results. So currently I don't have any table called employees. I am going to create an employee table, for example. This is a table I'm going to create. Let me quickly execute this command. Okay. And you can see the result, the returned row 0. Okay. If you will refresh it, you will see the number of table or the count of table will be changed. So I have this employee table. You can see it here. This is my employee table. Okay. Now, currently this table does not have any records. How can you check that? Simply execute a select query, which I'm doing right away. Let's say select star from employee. And when you will execute this query, currently you can see all the columns are empty. There is no records in this table. Okay. because that is my goal. I have to import the data from RDS to Redshift. Let's quickly check the status of RDS database. I'll refresh it and I'll wait for the status to be available. So currently it's backing up. Let's wait for the status of this Redshift to be available. In the meantime, I am opening Workbench, which I'm going to use. Okay, I told you you can also establish the connection from EC2 to your RDS. Okay, you can also establish the connection from EC2 to your RDS. Okay, you could launch an EC2 instance in the public subnet. You could set the required security group and you could establish the connection. Okay, but I'm going to use this client. Let's again see the status of your RDS database. Okay, it's available. Let's wait. So now I am going to create a connection. Open this RDS database instance and I will need the connection details. Okay, so I'll go here. I'll create a new connection. I'll give a name. Let's say RDS ETL demo. Any name you can give. Okay, you have to provide the host name. For host name, let's quickly copy the endpoint. So I'm copying the endpoint. I'll provide the endpoint here. I have to provide username. I have to provide password. Okay. So I'm providing a password here. And let's test the connection. The connection has been successfully made. So quickly connect to this database instance. And we are going to create a schema. So these are the default schemas, you can say. I'm creating a new database schema. I'm giving it as a name ETL demo. Apply and finish it. Okay. So now I have created this ETL demo schema. Now let's create a table employee in the RDS store. Okay. But this time, what I'll do, I will also insert the records into this table in RDS. Okay. You can see the query executed successfully. Now let's quickly insert the records. So these are the records I'm going to insert into my employee table. And again, I can see the insert query executed successfully with 4 rows affected. Means I have inserted 4 records here. Okay, how can I check that? I can say select star from employee. I can execute this query. And I will see the result. These are the results in different columns. Okay. So now I can see I have records in RDS, but I don't have any records in Redshift. You can cross verify that if you want. Go back here and cross verify it. There is no record. Okay. So now let's move back to our Glue job. I will open AWS Glue as a part of this particular dashboard. And again, if you want to read about AWS Glue, you can read from here. So AWS Glue provides you serverless data integration. It's a service under data lakes and analytics category. You can move data sets of nearly any size and prepare them for analytics and machine learning. So Glue has data integration tools for every skill set and manages all the infrastructure. Okay. You can see few announcements like what's new in the Glue. These are the announcement, benefits and features. You can see here. You can also have resources and tutorials. Okay. Now I'm going to create connections first. I have to create 2 connections, one for RDS, one for Redshift. Okay. So I have been navigated to the connection section. Okay. From here. So I'm here. I'm going to create connections. You can read info about it. You can manage your connections or use a connection in a job. So you can read info about it. Summary information about the connection created in your account is displayed in the resource list. And you can read few things about the connection from here. Managing connectors and connection. I'm going to create a connection. Let's create a connection for RDS. So I'm saying RDS connection. What will my connection type? My connection type will be RDS. What's my database engine? My database engine is MySQL. Let's choose MySQL. You can provide description, which is optional. You need to choose RDS database instance. This is my RDS database instance. What's the name of the database? The name of the database is ETL demo. I'll further scroll down. I can provide the username and password, and I can say create connection. So you can see connection successfully added. To begin your connection, you must create a job. So we are going to create a job soon. Let's create one more connection for Redshift. So I'll scroll up. I'll give a name, Redshift connection. Again, choose Amazon Redshift as a connection type. Description, that is optional. You can provide that. It will auto-populate the list of cluster and instances if they are available. You can see it has taken the database name also. This is your username, and you have to provide a password. You can also see, you can also choose a credential type as secrets, okay, and create a connection. So again, the connector successfully added. Now what's next? So see, I have created connection with RDS and Redshift. Now next thing is I will use crawler. So actually in AWS Glue we have three phases: discover, develop, and deploy. In discover phase, basically we understand the schema and metadata of our table. Okay. So here I have a crawler which is going to do this job for me. So I'm going to use crawler in AWS Glue, which will help me out to identify the schema, and it will create a metadata table for me. So we are going to create two tables here, one for RDS, one for Redshift. And that table will contain the information about schema and metadata, which will be later used for mapping purpose. Okay. So if we'll expand this, okay, you can see this is a AWS Glue Studio dashboard, but from here you can see you have the option for tables. So now if you want to create a table by yourself, you can add a table. You can also read about it. A table is the metadata definition that represent your data, including its schema. So a table can be used as a source or target in a job definition. Finally, a target is to create a job. Okay. So in order to create a job, we need these connectors, we need tables, we need databases. So here we are going to create that. That is going to help us out with the metadata information. Okay. So you can add a table, but at that point of time, you will have to choose or define schema. I don't want to do that. I am going to use crawler to create a table for me. So I'll go to crawlers, quickly create crawler. You can read info about it. You can see the crawler details section allow you to enter a name for your crawler and optional description. And you can read the use of the crawler. So crawler connects to a data store, progresses through a prioritized list of classifiers to determine the schema for your data, and then creates metadata table in your data catalog. Okay. Click on create crawler from here. Just give a name. Let's say RDS crawler. I scroll down. You can provide the description if you want. Go to next. I'm going to add a data source. So my data source will be JDBC. Okay. Connection will be RDS connection. And here I have to provide the path. The path have this format. Either you can provide database slash schema slash table, or you can provide database slash table. So if I'll go to RDS, this is my database name, ETL demo. And if I will refresh this and I will see the table I have created, I can see this is my table name, employee. So what I'm going to do, I am going to provide a database name slash table. So let's go back and say ETL demo and table name. Okay, let's provide that. You can cross verify if you want. Come back and say add a JDBC data source. Okay. Now the next thing is I'll go to next and I have to provide IAM role. Why IAM role? So IAM role is required by AWS services to perform actions on your behalf. Here, if you will see, Glue crawler has to read the data source. They have to identify the schema with the help of classifiers, and create a metadata table. So here Glue is performing some action. So I have to provide a role. So let me provide a role. I have already created a role for Glue, that is Glue ETL demo role. So for simplicity, I have assigned the administrator access to this role, but you always have to ensure the principle of least privileges. Please keep that in mind. Like whenever you are creating the roles, whenever you are configuring the permissions in real time, always keep in mind the principle of least privileges. Okay. I'll go to next. I'll have to create a target database in which this table will be created. So currently I don't have any database I can create. So I'm going to create two databases, one for RDS and one for Redshift. So let's say RDS database. You can provide description, database for table in RDS. Okay. You have to use the lowercase characters. So let's say RDS database. Okay. Or you can just modify to make it more informational. Database for table created by crawler. Something like that. Okay. Create database. Let's create one more for Redshift. So say Redshift database. You can provide database for Redshift table created by crawler. And finally, you can click on create database. Okay. Now I have two databases available because I'm going to create two crawlers, one for each connection. Okay. So let's choose a database. You can refresh it if you're not able to see that in the drop down. Choose RDS. Now you have to define crawler schedule. I will run this crawler on demand. Go to next. Review all the settings which you have provided in terms of crawler properties, data source and classifiers, security settings, output and scheduling, and finally click on create crawler. Okay. Now the next thing you have to do, you have to run a crawler. So as soon as I run a crawler, I have a table created in my AWS. Okay. So in the meantime, this crawler is creating a table. I can create another crawler for Redshift. So again, click on create crawler. Let's say Redshift crawler. Okay. You can scroll down. You can go to next. You can add a data source, this time for Redshift. I'm establishing a connection over JDBC. My connection is a Redshift connection. I have to provide database slash schema slash table. So in case of Redshift, this is my default database, this is my schema, and this is a table. Okay. So go back and let's say dev slash public slash employee. Okay. And finally, scroll down, add this data source, go to next, choose the IAM role. So I'm going to use the same IAM role, which I had used for my previous crawler. Again, go to next. This time I'm choosing Redshift database. For this crawler, also the frequency or the schedule will be on demand. Go to next, review all the settings you have provided. And finally, if you're okay with that, click on create crawler. Okay. Run this crawler and check the status of the existing crawler too. So if I'll refresh this, let's wait for this crawler state to be ready, and then we will see if there is any table got created. Okay. Let's wait for that. You can simply refresh it. In the meantime, if you want to know about Glue, you can open the Glue user guide. Okay. That is a very good documentation to start with. So here you can see this is a user guide or developer guide for Glue. You can see what AWS Glue is. It's a serverless data integration service that makes it easy for analytics users to discover, prepare, move, and integrate data from multiple sources. You can read more about it, how it works, concepts, components, converting semi-structured schemas to relational schemas, Glue types. So here if you come to components, you can see these are the components in terms of console, in terms of data catalog, crawlers and classifiers, Glue ETL operations, streaming ETL, and the Glue job system. If we'll go here, you can read about crawler and classifier. Glue let you set up crawler that can scan data in all kind of repositories, classify it, extract schema information from it, and store the metadata automatically in the AWS Glue data catalog. Okay, let's come back here. Let's refresh this. You can see table created. We can verify that. So for that, let's go to tables and refresh this. You can see there are two tables created, one under Redshift database, one under RDS database. If you open this, you can see the table details in terms of schema. So it has identified the schema with respect to the column name and data type you had provided while you had created a table. You can verify that. Okay, int varchar. Okay, you can see here int string and string. So basically the purpose of this crawler is to identify the schema, is to create a metadata table. Okay, now the last part of our demonstration is that we have to create a job. Our crawlers are ready. So go to jobs. It will open a Glue Studio in front of you. And now the next thing is we're going to create a job. So we have various options. You can use Spark script editor if you want to write a script. You can use Python shell script editor. You can use Jupyter Notebook. You can use Visual with Black Canvas, or you can use Visual with a source and target. So I'm going to use the first option, Visual with source and target. Okay. So what I will do, I'll scroll down, I will say create a job from a blank graph. Either you can just append it from here. What's your source? What's your target? Let's say my source is MySQL. My target is something, let's say Redshift. Okay, so you can go ahead from here. Or you can say create a job from blank graph. I'm using this one. Okay. So here also you can define the same thing, source, target, and action. Now this is a section where you can define transformation. Let's say you have to change schema, you have to perform joins, you have to execute some SQL queries, you have to detect sensitive data, and lot more things. You can see. If I will scroll down, you can see various sections which you can perform. Now I'm going to define source. So let me select MySQL here. The connection type will be RDS connection. The table name will be employee. You have to look up the name of the table from your JDBC source and enter it here. So this is my table name, employee. Okay. I'll go to target. You can save the changes. You can keep on saving the changes. Okay. I'll go to target. I'll choose a target as Redshift. I can choose a database, a Redshift database. I can choose a table. And finally, if I will scroll down, I can select this handling of new records. Do you want to handle the insert only record, or do you want to handle update and insert operation? So I'm choosing this one, insert only. Save it. We can change the name of the job. Let's say demo ETL job. Okay. Let's save the changes. And now if we go to the job details, you have to provide the role. So I will use the same role, do ETL demo role. I'll further scroll down. I will see that why it is showing red to me. I can provide a file name. So what happens when you create a job behind the scene, Glue will create a script for you, PySpark script for you. If you want to see that script, you can see it here. It has generated a script for you. Okay. You can edit the script if you want. I'll go back. This is the job detail I have provided in terms of job name, in terms of my script name, in terms of the role. Let's save that. It has been saved. And now I am going to run this job. You can see the run details. This is the run status. You can see glue version. You can see job name. You can see timeout setting, execution class, log group name, CloudWatch logs. So this is a log group name in the CloudWatch where you can see the logs if something is wrong. Okay. You can also have the performance and debugging recommendation here. We'll refresh that and we will see the status. Let's quickly verify one thing. Currently, I will vectors. If I'll execute a query, I don't have any records. So let's wait for this glue job to be completed successfully. I'll wait for a couple of seconds. In the meantime, if you want to run the script, if you want to just read out the script, you can read from here. You can see the info. You can also download it if you want to have that on your machine. It has a script stored in the S3 bucket. So from here, you can download it. It has been downloaded in my local machine if you want to read it, if you want to go through it. Okay. Let's check the run schedules. And let me refresh this. The status is still running. You can see the schedules. You can also create a schedule for your jobs. I have run it on demand from here. Okay. You can also use version controlling. So your job has not been committed to a version control. If you wish to do so, choose the push to repository option from the actions drop down. So you can see these options. You can integrate that with the AWS code commit. You can integrate that with the GitHub, the version controlling tools. Okay. Come back again. You can see the status is succeeded. And this time, if you will run this query again, you can see the result. Okay. So what we have achieved in this demonstration, we have achieved that we have moved the data from RDS to Redshift. So we have imported the data from RDS to Redshift. So that was the part of our demonstration, and that was something new I wanted to show you as a part of our Redshift series. Now, don't forget to clean all the resources in your AWS account if you don't want to get any charges. Okay. If you are under free tier, so always try to clean the resources once you are done with the practice. So with all these information, I will end up my demonstrations. So thanks a lot for being a part of this particular session with me. Stay safe, stay connected, and wish you all the best. Keep exploring AWS services. Thank you very much.